Welcome to the video on proportionality theorems, sometimes called side-splitter theorem, and the angle bisector theorem. Now these should feel fairly intuitive. The first one says anytime you have a line parallel to one side of the triangle and it intersects the other two sides, it's going to divide the other two sides in such a way that they're proportional. So what this is saying is if you have line TU that's parallel to side QS, what it will do is it'll make the ratio between T and R and Q and T equivalent to what we get when we compare segment RU and SU. So if I want to write this out as a proportion, the comparison between segment TR and QT is going to be the same as what we get when we compare RU with SU. Now that's one way of writing the proportion. We could have also written the same proportion as the comparison between side TR and RU is the same as what we get when we compare side QT and side SU. Notice that no matter which way we write this proportion, when we go to cross multiply, we're multiplying side TR times side SU in one direction, and multiplying side QT times side RU going in the other direction. So it doesn't make a difference which way you write your proportion, they are both correct. So that's the first one of the three that you need to know from this video. The second one has to do with angles. It says if a ray bisects an angle of a triangle, then it's going to divide the opposite side into segments whose lengths are in proportion with the lengths of the other two sides of the triangle. Now, like anything else, anytime you try to put something mathematical into words, it can sometimes be a little bit confusing. So I'm going to explain exactly what this means. What we're saying here is that if ray CD bisects angle C, in other words, if it creates those two angles that are congruent, then in other words, the comparison between opposite part AD and its adjacent side AC is going to be equal to the comparison between opposite part DB and its adjacent side CB. So if I write that out in proportion language, I'm going to compare AD to AC, and that's equivalent to what I get when I compare part BD with side BC. And again, if I so choose, I can write this proportion a little bit differently. The comparison between AD and BD is equivalent to the comparison between AC and BC. Because again, notice that no matter which way I choose to write the proportion, I'm also always multiplying AD and BC going in one direction and AC and BD going in the other direction. Those two proportions are identical, equivalent. All right, and then the last one, the third one, has to do with parallel lines once again. So it talks about three parallel lines intersecting two transversal. So in this picture, our three parallel lines are line R, line S, and line T, and I'm going to go ahead and mark those guys as parallel. Our two transversals in this particular case are going to be transversal M and transversal N. So it says when those two transversals intersect those three parallel lines, the parts of the transversal are divided up in such a way that they're proportional. In other words, if we compare the first side of that transversal with WY, that's going to be equivalent to what I get when I compare VX to XZ. Or to write it in mathematical terms, UW is to WY as VX is to XZ. Or another way of saying exactly the same thing, UW is to VX as WY is to XZ. Because again, notice that no matter which way we choose to write the proportion, when we cross multiply, UW and XZ are being multiplied together in one direction, WY and VX in the second direction. All right, so that concludes what I have for you on proportionality theorems and the angle bisector theorem. What I want you to do is up at the top of the next page, go ahead and summarize the key ideas and important understandings, and then see if you can apply what you've learned in this video to answer questions 2, 3, and 4 on page 17.